This week in CIST 2611, we'll look at Chapter 9, VPN Fundamentals. In this chapter, we'll look at our learning objective is to describe the fundamental functions of a virtual private network, common VPN technologies, and the elements of a VPN implementation and management. Our key concepts in this chapter include the virtual private network essentials, VPN models and architecture necessary for implementation, VPN transport and tunnel modes, VPN connection encryption, and VPN authentication authorization. So first we'll start talking about what is a virtual private network. So a VPN is a mechanism designed to establish a secure remote access connection across an intermediary network, which is frequently the internet. Now, some key functions for a VPN is it enables secure connection to a private network from a remote location. It facilitates control and management of network resources from a distance. And it also ensures highly secure communication channels within a private network. Some security features of a VPN is that it does utilize encryption and authentication mechanisms. And this is to provide the confidentiality, integrity, and privacy protection for your network communications. So for the confidentiality, it ensures that a private and secure communication. It safeguards data from unauthorized alteration is how it protects the integrity. And then for the privacy protection, it ensures the protection of the user identity and the data privacy. Now, a trusted VPN refers to a network configuration where the primary organization owns all of the infrastructure components. The primary organization possesses all the network infrastructure components, so it does have that ownership. This is one of the key characteristics of a trusted VPN. It utilizes a dedicated set of channels across leased telco communications. It maintains the privacy through physical isolation, even when you're using third-party equipment. And also, the trusted VPN, once again, implements encryption. This is for privacy and it ensures that secure communications, even over that public networks like the internet. Now, you also have a hybrid VPN that involves establishing a secure VPN over a trusted VPN connection. And then there you're combining the strength of both approaches. Now, remote access, this is different from remote control. So these are two distinct concepts within VPNs. Remote access is a remote access link enables access to network resources using a wide area network link connecting to a distant network. So this creates a local network link for the system that are not physically near that network. The client system can perform all the tasks that a locally connected computer can, or a locally connected client can. And also, network administrators can also impose restrictions on the resources and services that are accessible to remote access VPN clients. So when we consider the scenario that a LAN and a remote client both have independent connections to the internet, these connections are independent of each other. Now, in the LAN, usually that LAN connection is permanent or dedicated connection. And that's supporting both inbound and outbound activities with the internet. The remote client can have either a dedicated or a non-dedicated connection to the internet. So this is a new network connection is established from the remote client to the LAN across the intermediary access. And this new network connection is the VPN. Some secure VPN concerns is that all VPN traffic must be authenticated and encrypted. So a VPN without authentication is not private, and a VPN without encryption is insecure. You also want to have consistent security parameters. So all VPN endpoints must adhere to the same security parameters and algorithms. So this ensures that uniformity in the security measures across all network access points. You also use encryption key sets. So each VPN tunnel must possess corresponding encryption key sets for securely exchanging encrypted content. So this ensures that the secure communications and the confidentiality of the communications. You also want a unified security policy. So you want the same security policy that should govern all of your VPN endpoints. This provides consistency and make sure that people have the adherence to the security policies and your virtual private network adheres to those policies. You also want to have proper encryption protocols that prevent external third-party interference. So ensuring the VPN's resilience against unauthorized access and cyber threats helps with that protection against external threats. The encryption strength is also a concern for VPNs. So if you have weak encryptions, that render a secure VPN, those can be vulnerable to various attacks. So you want to make sure that you choose a robust encryption protocol, and that is very important for maintaining a secure VPN. Now, a trusted VPN's concerns, one will be access control by the provider. So based on that provider's ability to limit and control access to the VPN's content, only authorized entities have access to that VPN. Another concern is the provider's control over the channels. So only the trusted VPN providers should have that capability to modify the channels or pathways to the VPN. You also have the data manipulation authorization is a concern. And you want to make sure that only trusted VPN providers can add, remove, or change the data within the trusted channel. Also, addressing and routing within the trusted VPN. This must be defined before the VPN goes online. And this is to ensure a clear, secure pathways for that data transmission. You also have service levels agreements concerns. So these are services that are usually predefined in the service level agreement. So you want to make sure that you have a clear understanding of the agreed upon services and responsibilities for your VPN, your trusted VPN. Now, tunneling protocols, they encase the original network protocol and it allows it to traverse the intermediary network securely. We do have some types of protocols that we'll talk about. For example, some of the dominant forms of secure VPNs. Most of these you'll use the IPsec or the SSL/TLS, and that is our tunneling and encapsulation protocols. And we see some other protocols that are used to create VPNs. Point-to-point tunneling protocol, the SSH, SSL, and so forth. So now we're going to talk about the benefits of developing a VPN. First is it's the productivity. So it allows workers to access and utilize resources efficiently, and this facilitates timely completion of tasks. Also, remote access from a variety of devices such as your laptops, tablets, mobile phones. This enables your workers, your organization to complete their work from different locations. Workers can also connect to the company LAN securely from various devices and locations, reducing risk associated with insecure access locations. And then finally, cost savings is one of the benefits of developing a VPN. So you have your telecommuters and traveling workers, they save on long distance charges. Businesses utilize local internet links for VPN rather than having a dedicated lease line between each location. And that helps them save on their cost saving and save on expenses. So other benefits of developing a VPN include reduced equipment cost. Now this is compared to traditional networking solutions. Also, VPNs offer unlimited geographical connectivity. This enables seamless communications and collaborations across different locations. You also have increased flexibility and versatility of worker locations. So the workers are able to um, get that flexibility in choosing their work locations and allows them to provide a more adaptive and efficient workforce. You also have the improved privacy and confidentiality due to strong encryption. So that strong encryption ensures improved, like I said, privacy and confidentiality of that data during the transmission. And this is there to safeguard that sensitive information. VPNs also verify the integrity of the transmitted data, ensure that the information reaches its destination intact and unaltered. They also offer a fully scalable global infrastructure and architecture, um, so that's able to change and accommodate the growing needs of businesses that are expanding their networks globally. VPNs also offer rapid development options, allowing your organizations to establish the secure network swiftly. They offer uh, flexible integration with existing networks and technologies, so you have that seamless incorporation into your existing infrastructure. VPNs also often lead to a faster return on investment than compared to traditional WAN infrastructures. They also reduce the dependence on long distance carrier solutions, which once again offer cost effective alternatives. And VPNs, finally, they also lessen the support burden on the ISPs. So this allows you to streamline your network management process. Now, there are some limitations on a VPN. VPNs do not guarantee quality of service, so that leads to potential variations in network performance. When you use a VPN over the internet, it can encounter latency, fragmentation, traffic congestion, drop packets. And this is something that could impact the user experience. Like I said, the fragmentation of the packets may occur. That's affecting the smooth flow of data and potentially causing delays. Also, without strong encryption, data may expose while in transit over the network, which compromises the confidentiality. You also have endpoints that may be vulnerable to cyber threats, presenting that security risk to the overall network. And one of the other challenges of a VPN is providing technical support for VPN related issues remotely. This can be a challenge and it can affect the resolution process. Now, there are some effective VPN policies. So, when you're designing and planning your VPN policies, some things you need to consider is, for example, the hardware and software solutions. You want to evaluate the benefits and drawbacks of both the software and hardware VPNs. You do this during the design and planning phases. You also want to enforce stringent multi-factor authentication on all VPN connections. So you want to ensure that multiple layers of validation for users are used. You want to implement strong access control restrictions on all VPN connections. So you want to define who has access to what specific resources. You also want to clearly define how the VPN will be managed, through which interfaces, and by who. So you want to ensure that you have the proper administration for your VPN. You also want to explore the complexities of patch management over the VPN. You want to address potential challenges that you may find in maintaining that security system or that system security. You also want to define the mechanisms for providing remote technical support for VPN telecommuters. You want to enable detailed auditing on all activities that occur across or through that VPN. You also want to define distinct qualifications for granting users access to telecommuting VPNs. And this is to help to ensure security compliance. Finally, you want to prescribe user training requirements for all VPN activities. So you want to make sure that your users are well versed in the security protocols. Now, three of the VPN deployment methods we will talk about include Edge Router, Corporate Firewall, and VPN Appliance. So your Edge Router development, the VPN deployment can be achieved through the configuration of Edge Routers. So the routers manage and secure the connection between the internal networks and the external networks, and that allows them to facilitate VIP functionality. Now, VPNs can also be integrated into corporate firewalls, and this is for a comprehensive security approach. So the firewall acts as an additional layer of protection while managing the VPN connections. For the VPN appliance deployment, the VPN appliances they're specialized devices designed for VPN functionalities. They offer a dedicated solution for secure network connections. So these appliances often come with a simplified management interface, and it makes that VPN deployment more streamlined. Now, some of the architectures we'll talk about include remote access, site to site, and host to host. So, remote access, you remove remote access VPNs. They allow individual users to connect securely to a private network from remote locations. The site to site establishes secure connections between different physical locations or branch offices. And the host to host VPN, this enables secure communications between individual devices. Now, remote access, this is also known as host to site VPN. So it facilitates that single host VPN connection to a LAN site. Now, some key characteristics of the remote access is that it is user centric. So this is something that's primarily designed for individual users accessing the LAN from a remote location. One of the benefits it does offer flexibility for commuters or traveling employees that may require secure access to the organization's LAN. It does have some benefits. It's once again individually connective, so it allows that single host to securely connect to that centralized LAN. And it also provides secure remote work. So it enables that remote work without compromising the security. Now, the site to site VPN architecture, this is also known as LAN to LAN or LAN to WAN VPN connections. You also have the WAN VPN connection between the LANs. So this facilitates secure connections between the LANs over that public network. Couple key characteristics of the site to site. It does have that network interconnections. So you can establish secure connections between different physical locations or the branch offices. You also have distributed LAN, so you can use this as an inexpensive mechanism to create a single distributed LAN. Now, some benefits of this is it does have that continuous connectivity. So it ensures continuous and secure communication between interconnected networks. It is also a cost-effective network extension. So by using a site-to-site VPN, it provides that cost-effective way to extend a LAN over that geographical distance. Now, with the site-to-site VPN, when we talk about this with remote users, there are a couple of things we can talk about. One is the hybrid concept. So this combines the site-to-site VPN concept with remote access VPNs. You also have the versatility, so it allows that secure connection between the LANs while also accommodating those remote mobile users. Now, the host to host is also known as the client to server, remote to office, or remote to home VPN. So it establishes a direct VPN connection between one host and another. So this operates over the public network or within a private network. So when we talk about it over a public network, it provides that connection that is secure from the public. When we talk about it with a private network, it adds an extra layer of security for mission critical or highly sensitive transactions. Now, extranet access with VPNs. So that you have with this, you have your endpoint positioning. So you want to position those VPN tunnels endpoints at the inside or the inside of the perimeter of the extranet. So this serves as a pathway for external entities like business partners, distributors, suppliers, to allow them to access corporate resources securely. So this is done to prevent unnecessary access to the private LAN, and you can be able to ensure control connectivity through this. Now, the VPN is linked to the extranet rather than the DMZ. It does provide greater security to those remote entities, so you minimize the risk at the VPN termination point. So, tunnel mode encryption. This protects the entire original IP of packets, header, and payload. The encrypted packet becomes the payload of a new IP of packet with a new IP header. This assures that the identities of the original communication endpoints are kept confidential. And this is something that's frequently employed by VPNs linking network sites or providing secure remote access. Now, the transport mode encryption protects only the original IP packet's payload. The encrypted payload retains the original IP header. It protects, once again, only the payload, leaving the identities of the communication endpoints exposed. So when we talk about the relationship between encryption and VPNs, secure VPN traffic, this is characterized by encryption. And what it does, it provides a robust layer of protection for the data in transit. Now, some trusted VPNs may choose to employ or forego the encryption based on their specific security measures and policies. Now, cryptography, this is the art and science of changing information to prevent unauthorized understanding. So this involves both encryption and decryption process. And modern cryptography relies on algorithms to ensure secure communication. So with the relationship between encryptions and VPNs, we'll define encryption as the process of converting original usable data, which is plain text, into unusable, an unusable form, a chaotic form called ciphertext. So you're taking what is easily read and you're making it unreadable. Decryption is the process of converting the ciphertext back into the plain text. Now, this does require the use of a specific decryption key that's used to restore that original data. Now, the algorithm is a set of rules or procedures, often mathematical in nature, governing the encryption and decryption process. Encryption algorithms utilize a key to control the process, and the encryption key is a unique and secret number that governs both the encryption and decryption. Now, when we talk about the bit length of the algorithm's key, that determines its key space. That's influencing the strength and security of the encryption. Symmetric cryptography is based on the algorithms that utilize a single shared key. So, symmetric implies the use of the same key for both the encryption and the decryption. The identical key must be shared among all communication partners in the same session. Some characteristics of symmetric cryptography is that it is very fast in comparison to the asymmetric cryptography. We have a bunch of different examples of different types of cryptography algorithms. One of the difficulties in symmetric cryptography is how to share the key. So in this case, we've got the asymmetric cryptography. So this is based on algorithms using either key pairs or special mathematical mechanisms. So asymmetric cryptography uses key pairs or using key pairs. This is commonly known as public key cryptography. Asymmetric indicates the use of different keys for encryption and decryption. Now, the key pair set consists of a private key and a public key. So the private key is going to be kept secure and private at all times. The public key is put out for open for the public use and access. Now, once again, this is very slow in comparison to symmetric cryptography. And it's best suited for identity proofing and key exchange. This makes it more suitable for specific security purposes. So if you were using asymmetric cryptography, you would use your private key to encrypt the data. Once it's sent, the receiver would use your public key to decrypt it. Now, digital signatures, they serve the purpose of proving the identity of the sender. So this is not encryption. So they do not provide confidentiality protection. Digital signatures are there for identity verification. So they're there to authenticate and verify the legitimacy of the sender. Now you can, while these digital signatures do not involve the encryption of the message content, there is a confidentiality aspect. Hashing can enhance the overall security of digital signatures. Now, hashing is a cryptographic function that takes the input of a file or message and generates a fixed length output. The output can vary in size, but the output remains fixed based on the hashing algorithm used. Now, some of the characteristics is that hashing does not modify or alter the original data. Instead, it uses the data to create a hash value as a new data item. Also, the integrity of the data is verified through a complex mathematical functions that are embedded in the hashing algorithm. Hashing is also a one-way function. This means that it cannot be reversed to obtain the original data from the hash value. And as you see, that VPNs employ hashing, and this is often part of a digital signature as a method to confirm that transmitted data has retained its integrity. Now, digital certificates consist of public key and private key pairs, and they're digitally signed by a trusted third party. The third party involved in the process is a certificate authority, and they're responsible for verifying the identity and issuing digital certificates. So the process for this is the CA first verifies the identity of the individual or organization seeking a digital certificate. Now, once verified, the CA crafts and issues that digital certificate, and that's to ensure the security of the key pair. VPN authentication is the process of confirming or proving the identity of the user. Authentication is the process of confirming and or proving the identity of the user. This is something that's highly important for VPNs, given that they enable external entities to connect to and interact with a private network or systems. And our VPN authentication takes place on two levels. You also have in connectivity. So when the user connects to the VPN, and also authentication forms a foundational element in ensuring that the secure access of the authorized user. Now, VPN authorization, this involves controlling what users are allowed and not allowed to do within the system or network. This is something that's also known as access control. This is something that we clearly define in the policies. So you have those clearly defined policies, and those will establish the activities that are supported or restricted for VPN connections. The primary focus is on defining the users permitted to establish a VPN connection with our VPN authorization. Now, some key considerations of this include essential connectivity. So the VPN connectivity should align with the worker's assigned tasks and responsibilities. So you want to make sure that unnecessary access is restricted, and also that the access should also any access to the resources across the VPN should be restricted, even for authorized users, based on your defined policies. So in this chapter, we've talked about the virtual private network essentials and how a VPN serves as a mechanism for establishing secure remote access. And those connections are across networks that are often utilizing the internet. We talked about the different types of models and architectures necessary for implementation, and how they are necessary for effective implementation, addressing a wide range of connectivity needs. We discussed transport and tunnel modes, and how they're used to secure communications and create a secure pathway. We've also talked about VPN connection encryption and how it plays a pivotal role in the VPNs in ensuring that secure data transmission. Finally, we talked about VPN authentication and authorization and how it is an important process to confirm or proving the identity of the user, especially given the external connectivity VPNs provide, and how the VPN authorization involves controlling the user's activities and access within the VPN system, and make sure that it aligns to the defined policies and restrictions.